Okay, so measures of spread day 2. So the last note we looked at quartiles and box and whisker plots. Today we're going to look at variance and standard deviation. Now variance is essentially it's how far something varies from the mean set. It's calculated using this formula, which I'll show you how to do later. It's a lot easier if we look at a chart, but essentially the variance and what the definition is saying is if we have a whole bunch of data points and we drew the line of best fit, each of these data points would make a little square. And this is the variance. It's going to make the least amount of squares, the mean of the squares. It's going to make the average square size. Okay? There's a lot more to it, but that's essentially what it's talking about. Now, the standard deviation is the typical distance a point is away from the mean. So if we had a mean point, it would be the distance that each of the values are from that point. So the greater the standard deviation, the greater the variance, and the greater the distance of all of the actual values are away from the mean. So if we had like a low standard deviation, if our mean point was right here, all of the points would be kind of right around it. If we had a high standard deviation, if the mean point was still kind of in that same spot, all of the points are further away. Calculate the standard deviation. So standard deviation is the square root of the variance, and the variance is this big long formula. But really what we can do is what we're going to do is make a chart. Okay, so the first thing we need to do is create the chart. We have the data minus the mean. So what that means is we need to find our mean value. Okay, and our mean value is all of the values, 48 plus 62 plus 81 plus 75 plus 77 plus 68, all divided by the number of values, which is 68.5. Okay, so the data value minus the mean value. So 48 minus 68.5, negative 20.5. 62 minus 68.5, negative 6.5. Now 81 minus 68.5 is 12.5. This is 6.5, this is 8.5, and negative 0.5. Now this next column, we're just squaring all of those values. Now the biggest mistake people make is that they are keeping that negative. When we square a value, we don't keep the negative. So the negative 20.5 becomes positive 420.25. The negative 6.5 becomes positive 42.25. All of the numbers are going to just become positive because we're squaring them. Two negatives multiplied together becomes a positive. What do we got here? So this is 42.2. And I'm just kind of going through these. There. Then we have to add them up. The first column you don't have to add up, it doesn't actually matter. The next column we do, so we have 72.25 plus 42.25 plus 156.25 plus 42.25 plus 420.25 plus the 0.25 at the bottom. We get 733.5. After that, if we go back to the formula, we've actually done this whole top part now. Okay, all we have to do, so we have an answer for all of that. All we have to do is divide by the number of data points we have. So our variance is 733.5 divided by 6. So we get 122.25. Now the standard deviation, we just square root that number. we get 11 we'll call it 1. Okay, 11.1. So what that means is that each point is about 11.1 values away from the mean. So on average, the points are within 11.1, or they're from 79.6 down to, and we're just subtracting here, 57.4. So all I did was take the mean and add the standard deviation and subtract the standard deviation. All right, example 2. So Jared scores 5 goals in 1 game, 2 goals in 4 games, 1 goal in 4 games, and no goals in 1 game. So we've got total number of goals for Jared, and then it goes through and gives Henry a whole bunch. So Jared's total number of goals. So he's got 5 goals in 1 game, 2 goals in 4 games. So we've got 5 times 1, 2 times 4, 1 times 4, and 0 times 1. So he's got 5 goals up here, 8 goals up here, 4 goals up here, and 0 goals up here. So he scored 5 plus 8 is 13, plus 4 is 17 goals. And he's played 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 games. So he scores on average 1.7 goals per game. Now, Henry scored 3 goals in 2 games. So we got 3 times 2. 2 goals in 3 games, so 2 times 3. And 1 goal in 5 games, 1 times 5. So he's got 6, 6, and 5. Okay, so he's got 6, 6, and 5, which again, 17. And again, 10 games, again, 1.7. This is trying to show you that this data doesn't necessarily show us who the better goal scorer is. Both of the players are scoring 1.7 goals a game. Okay, now I think that this is an easy one to see who the better scorer is, but what we're going to do is we're going to go through and we'll find the actual standard deviation and the range. So the range would be the highest minus the lowest. So his range is he scored 5 goals in 1 game and 0 goals in 1 game. So his range is 5. Now his standard deviation, we know the mean value. We've just found the mean. The mean is 1.7. So what we're going to have here is our data value minus the mean, and we're going to go through and we're going to actually find the variance and standard deviation. So his mean value is 5 minus, that is going to be 3.3, 0.3, 0.3, 0.3, 0.3, and then we've got negative 0.7, negative 0.7, negative 0.7, negative 0.7, negative 1.7. Now remember, when we square these values, they're all going to become positive. So the first one is 10.89. The next one, so we've got 0.3 squared is 0.09, and that's 0.09, 0.09, 0.09, and then we've got 0.7 squared is going to give us 0.49, 0.49, 0.49, 0.49, and then 1.7 squared is 2.89. Now we have to go through and add all of these together. So if we're adding all of these together, we've got 4 times 0.09 plus 0.49 times 4 plus 10.89 plus 2.89. we get 16.1. So 16.1. Now we're going to divide that. So our variance is equal to 16.1 divided by 10, which is 1.61. And then our standard deviation, now there are symbols for this, but I'm not going to get into that, is 1.61 square rooted. So that is going to give us 1.2, we'll go to 1.27. So he's got a range of 5, meaning he's difference in top and bottom is 5, and a standard deviation of 1.27. Okay, let's look at the next person. So here, our data values. So we know our mean is 1.7. So our data value minus the mean. So 3 minus 1.7 is 1.3, 1.3, 0.3, 0.3, 0.3, negative 0.7, negative 0.7, negative 0.7, negative 0.7, negative 0.7. So then we're going to just take those values and square them. So we get 1.69, 1.69, 0.09. And notice again, all of these values are positive because we're squaring something. It always makes it positive. We're never going to have negative values. That's the biggest mistake people make when they're doing this calculation. So now we're going to add all of these together, plus 0.09 plus 0.49 times 5. So here, when we add them all together, we get 6.1. Now our variance is 6.1 divided by 10, which is 0.61. And our standard deviation is the square root of that, which is 0.78. So what this is showing us is that while they have the same mean, they both score on average 1.7 goals. Henry is scoring between approximately 0.9 goals and 2.5 goals every game, whereas Jared is scoring 0.3 goals up to 3 goals a game. So his standard deviation is larger, so he's not as consistent. So Henry is almost consistently going to score you at least 1, if not 2 goals a game, whereas Jared could score you 0 or up to 3 goals a game. So this Henry is the more consistent player, and you'd probably call him the best.